Hello guys, my name is Craig and welcome to Peri Solutions. Today I'm going to show you how we integrate expressions of the form ax plus b raised to the power n, right? So basically we're saying this is a linear function that is raised to the power of n, right? So we looked at how we would integrate, say for example 2x minus 3 squared, right, with respect to x. Right. So now this linear function is being raised to the power of 2. Right. And from what we've done so far, we can of course expand. Expand, then integrate term by term. But now there's situations whereby this power of n can be negative. Right. Say it's now minus 2. Or even a bigger number, say we've got to the power of 4. You figure out that trying to expand it will take time. So there's a shorter form that we use when we need to expand specifically linear functions that are raised to the power of n. So the result that we use is that we say for the integral of ax plus b raised to the power of n with respect to x, right? We say 1 over. So first of all, we have to find the integral, the derivative of what's inside the brackets, which is an a. Then we multiply that a by n plus 1. Right? And then we simply say this result multiplied by ax plus b raised to the power of n plus 1. Right? So what we would do if it was differentiation, right, from the chain rule, we're going to find the derivative of what inside the brackets, then multiply by the power, right? But now since integration is the reverse, we shall divide by the integral, by the derivative of what's inside the brackets, then multiply by n plus 1, and then times ax plus b raised to the power of n plus 1. So this is the result that we use. Now let's attempt those questions that require us to find the integral. So with number 1, we want to find the integral of 2x minus 1 raised to the power of 6. So we say this result would be 1 over the derivative of what's inside the brackets, we get a 2, multiplied by the power n plus 1. 6 plus 1, you get a 7. Then we're saying this times 2n plus 1 raised to the power of n plus 1, which is 7. Then plus the constant of integration c. So this will be equal to 2x minus 1 raised to the power of 7 over 14 plus c. So this is for number 1. And then for number 2, we have to raise this into the numerator. So it will be the integral of 15 times 1 minus 3x raised to the power of minus 6 with respect to x. And since 15 is a constant, we can just take it out and say 15 multiplied by the integral of 1 minus 3x raised to the power of minus 6. We are saying 1 over the derivative of what's inside the brackets, that's minus 3. Minus 3 plus the power n plus 1. Minus 6 plus 1, you get a minus 5. Then we're saying this times 1 minus 3x raised to the power of minus 6 plus 1, we get a minus 5. Then plus the constant of integration c. And this will give us 15 over minus 3 times minus 5 plus 15. 15 and 15 cancel. We get 1 over, sorry, we get 1 minus 3x raised to the power of minus 5 plus c, constant of integration. And then now number 3, same situation. We have to first of all break it down. So allow me to erase this part. Number 3, we have to break it down. So if we break it down, we are saying that removing this square root sign, right? So this is 6x minus 5 raised to the power of 3, then the square root of that. Right, so it's more like this, then the square root of all of that. So now this will be the same as the integral of 6 multiplied by 6x minus 5 to the power of 3. To the power of 3 times the power of half, that's the power of 3 over 2, with respect to x. So we know we can take out the 6, that is a constant, then multiply by the integral of 6x minus 5 raised to the power of 3 over 2, which we are saying 1 over the derivative of what's inside the brackets, that's a 6, plus the power plus 1, minus 3 over 2, 3 over 2 plus 1, that will give us a 5 over 2. Then times 6x minus 5 to the power of 3 over 2 plus 1, that's a 5 over 2, plus c being the constant of integration. And then we can further on simplify to get 6 times 2 into 6, that's 3, so 1 over 15, times 6x minus 5 raised to the power of 5 over 2 plus c, constant of integration. 6 over 15, reducing that, will give us 2 over 5. 6x minus 5 raised to the power of 5 over 2 plus c. So this is the result that we get for number 3. And then now for number 4. Number 4, what we have to do is that removing the square root sign, we're saying this is 2 plus 3x, right, raised to the power of half. Then we are raising this as well to the power of 5, such that to the power of half times 5, we get to the power of 5 over 2. So I want to find the integral of 2 plus 3x raised to the power of 5 over 2 with respect to x. So same thing, right? We're saying 1 over the derivative of what's inside the brackets, that's a 3, right? 3 times to the power of n plus 1. 5 over 2 plus 1, that will give us a 7 over 2. Then times 2 plus 3x raised to the power of n plus 1, that's 7 over 2. Plus c being the constant of integration. Such that we say this will give us what? This will give us 21 over 2. And 1 over 21 over 2, that is 2 over 21. 2 over 21 times 2 plus 3x to the power of 7 over 2 plus c. So this is what we get for number 4. Right, and then now moving on to number 5. Number 5, what do we have? We've got f prime x being equal to 1 over 5x minus 3 raised to the power of 4. And f of 1 is equal to, this is supposed to be minus 90. F of 1 is equal to minus 90. And then we're required to find f of x. So first of all, we have to rewrite this in such a way that it is f prime x is equal to 5x minus 3 raised to the power of minus 4. And then we know that if we integrate this gradient function, we will get f of x. So we are saying that for number 5, allow me to erase this part. So we're saying that for number 5, we're saying that f of x would be equal to the integral of 5x minus 3 raised to the power of minus 4 with respect to x. Then we're saying 1 over the derivative of what's inside the brackets, we've got 5, multiplied by n plus 1. Minus 4 plus 1, we get a minus 3, then times 5x minus 3 raised to the power of minus 4 plus 1, that's minus 3, plus c being the constant of integration, such that f of x would be equal to minus 1 over 15 times 5x minus 3 raised to the power of minus 3 plus c. But we're told that f of 1 is equal to minus 90. So this condition is going to help us find the constant of integration. So we're saying that f of 1, in place of x, if we put 1, that result should give us minus 90. So we're saying minus 1 over 15 times 5 times 1, that's just 5. 5 minus 2, so 5 minus 3, we get a 2. Then 2 to the power of minus 3 plus c should give us minus 90. And then minus 1 over 15 times 2 to the power of minus 3, that's 1 over 2 to the power of 3, which is 1 over 8 plus c minus 90. then this will give us minus 1 over 120 plus c is equal to minus 90. Then if we take this to the other side, c would be equal to minus 90 plus 1 over 120 minus 90 plus 1 over 120. That will give us a quite weird answer, which is minus 1799 over 120. Okay, so that's what we get. So let's just go through over it again. So for number 5, we are saying that we rewrite this, right, and put this in the numerator such that it's 5x minus 3 to the power of minus 4. And then if we integrate this, we get our f of x. So integrating, we're saying 1 over the derivative of 5x minus 3, that's a 5, times minus 4 plus 1, that's minus 3. Then we raise this to the power of n plus 1, which is minus 3, plus c being the constant of integration. Then we get minus 1 over 15, this, that. So this being our f of x, we're told that f of 1 is equal to minus 90. Right? So in place of x, if we put 1, right, that result should give us minus 90. So 1, we get 5 minus 3, that is a 2. 2 to the power of minus 3, right, minus 1 over 15 times 2 to the power of minus 3 plus c should give us minus 90. And then 2 to the power of minus 3, that result gives us 1 over 8. So simplifying this, we get that. So this is the value of c, such that f of x in full, f of x would be equal to minus 1 over 15 times 5x minus 3 raised to the power of minus 3, then minus 1799 over 120. Alright, so this is what we get for number 5. This is the result that we get for number 5. For the f of x that is required of us. Now let's move on to number 6. Number 6, allow me to erase this number 5 from here. Just need to create some space. So, okay, I can erase this part as well. Alright. So for number 6, we're told that d squared y by dx squared is equal to 1 over 4x plus 1 raised to the power of 7. And then when x is 4, dy by dx is equal to 6. And when x is 4, y is equal to 0. Find y in terms of x. Right. So first of all, we shall integrate the second derivative to get dy by dx. So dy by dx, this is for number 6. dy by dx is equal to the integral of 1 over 4x plus 1 raised to the power of 7 with respect to x. Then we are saying that 1 over the derivative of what's inside the brackets, that's 1 over 4, times n plus 1. 7 plus 1, we get an 8. Then times 1 over 4x plus 1 raised to the power of 8 plus c being the constant of integration. Then this will give us a 2, 1 over 1 over 2, which is 2, 1 over 4x plus 1 raised to the power of 8 plus c. This is our dy by dx. But we've got a condition that when x is equal to 4, dy by dx is equal to 6. So that is going to help us find this constant of integration. So we're saying that 6 is equal to 2 times 1 over 4 times 4, we get a 1. Then 1 plus 1, we get a 2. 2 to the power of 8, so 256, I think, yes. 256 plus c. So 2 times 256, then plus c. This will give us 512. So 6 minus 512 should give us c, which will be minus 506. So we're saying that dy by dx is equal to 2 times 1 over 4x plus 1 raised to the power of 8 minus 506. Right. But we're required to find y in terms of x. So we shall now integrate as well this gradient function to get our y. So y would be the integral of 2 multiplied by 1 over 4x plus 1 to the power of 8 minus 5 or 6 with respect to x. And this will give us, if we take out the 2, since it's a constant, 2 times the integral of 1 over x plus 1 over 4x plus 1 raised to the power of 8. We're saying that 1 over the derivative of what's inside the brackets, that's 1 over 4, times n plus 1. 8 plus 1, we get a 9. Then times 1 over 4x plus 1 to the power of n plus 1, that's also a 9. Then minus 5 or 6 times the derivative of x to the power of 0, that will give us a 0, plus c being the constant of integration. Then now if we simplify this, we get 2 times 1 over 9 over 4, which is the same as 2 times 4 over 9. That will give us 8 over 9. Right, 8 over 9, 1 over 4x plus 1 to the power of 9, minus 5 or 6x plus c. Right, this is our y. So now we shall use this condition which says when x is equal to 4, y is equal to 0 to find this constant of integration. So we're saying that when y is equal to 0, x is equal to 4. So now 1 over 4 times 4, we get a 1. Then 1 plus 1, we get a 2. 2 to the power of 9, that's 512. So 2 to the power of 9, that's 512. And then 512 times 8 over 9, right? We get 455 in 1 over 9, then minus 106 times x. Our x being 4 in this situation, yeah? Right, to get quite a weird answer as well, which would be 0 is equal to minus 14,120 over 9 plus c. So in other words, c is just 14,120, such that y, in actual fact, y would be equal to 8 over 9 times 1 over 4x plus 1 raised to the power of 9 minus 5 or 6x, then plus 14,120 over 9. Right. So this is how we calculate expressions of the form. Specifically, this is how we integrate expressions of the form ax plus b raised to the power of n. Please don't forget to leave a comment, drop a like, and subscribe. Thank you.